Hello everyone, my name is Karmawanchu with student number 988507. Today I'm presenting assessment 2 for MIT 121, which involves two Python data visualization program built with Streamlit. The task 1 replicates the key statistics table from the ABS Labor Force release for March 2026. That's the Australian Bureau of Statistics monthly employment data. And task 2 reproduces figure 2 from a CDC research paper, an iterative horizontal bar chart of 10 leading underlying causes of death in the United States in 2023. I'll walk through the original data, demonstrate each GUI running live, and then explain exactly what each part of the code does. So moving on to the task 1, the app displays the two tables, the trend estimates and the seasonal adjusted estimates, both from ABS March 2026 labor force release. Each table has 7 columns, the indicator name, then Feb 26, March 26 values, then monthly change as a percentage, yearly change, and yearly change as a percentage. The five indicators are employed people, unemployment rate, under unemployment rate, participation rate, and monthly hours worked. So the key data points from this table are: in March 2026, 14,762,800 Australians were employed, 30,800 from February, a 0.2% monthly increase. The unemployment rate held steady at 4.3%, unchanged month on month. The participation rate was 66.8%, down 0.2 percentage points year on year. And monthly hours worked reached 2015 million, up 2% on previous year. These figures are hard-coded as Python list in the script. I'll explain why the design choice was made in code walkthrough. Now I'll show the live demo of the Tux One code. So this is the code for the Tux One. Now I'll open the terminal. So you can see the app opens in the browser with a sidebar on the left and two tables in the uh, main area. This replicates the layout of the actual ABS website. The sidebar shows the page navigation item, which is 15 items with key statistics highlighted because that is our active page. The first table is the trend estimates, and below is the seasonal adjusted table. Each has download button and download button and tail SN bar above it, matching the ABS visual style. If you look closely at each table, there is a diagonal watermark behind it. It says MIT 121988507. That is embedded in the HTML that generates each table. Hovering over any row highlights it in the blue. light blue, which is a CSS hover effect. So now I'll walk through the code. So this is the code for the Tux 1. The script starts with the two imports, the Streamlit, the GUI framework, and nothing else. No pandas, no data loading libraries because all data is already hard coded. st set underscore page underscore configuration is called first streamlit requires this to be the very first streamlit command. It sets the browser tab title, the favicon emoji and layout wide, which stretches the content to fill the full browser width. Next, in the large st markdown, call with a style tag inside it. This imports the source Sense 3 font from Google Fonts and defines all visual classes used throughout the app. The key classes are ABS table for the table styling, including the header borders and alternating row background, nav link and nav link active for the sidebar items, section SN for the tilt-top bar above each table, and WM text which positions the diagonal watermark using CSS absolute positioning and a CSS rotation transform of -20 degrees. The sidebar is built using the Streamlits with st.sidebar contact manager. Uh, Inside it, we loop over a list called nav items. So each element in nav item is a two-value tuple, the label text and a boolean for whether it is currently active. Only key statistics is true. The loop reads this boolean and assigns either nav link active or nav link as a CSS class. The active class adds the left blue border and bold weight. This the build function the build table function, this is the most important function in Tux1. It takes the two arguments, header and list of column, header, strings, and rows, a list of tuples where each tuple one data row. So def build underscore table. Inside the function, we first build the header row. We loop over the headers list. Some header strings contain black splash, for example, monthly black splash and change. We call splash on backsplash and to break that into two parts, then rejoin them with an HTML BR tag. And this creates a two-line header cell, which is how the ABS site displays it. We then loop over the rows list to build the table body. Each element in a row tuple becomes a TD cell. The entire table is wrapped in a div with a class WM wrap, and inside the div there is another div with the class WM text. The second division is the watermark. It sits absolutely positioned in the center and uses CSS to rotate diagonally. The function returns the complete HTML string, which is then rendered by st.markdown with unsafe underscore allow underscore HTML set to true. So that the data constants, the headers, trend rows, and seasonal rows are all defined at model level before any streamlets calls. Trend rows and seasonal rows are a list of 7-element tuples. Each tuple matches the 7 columns. The values are already pre-formatted strings with commas, percentage signs, and points notation. There's no calculation happening at runtime. This makes the code simple and easy to verify against source data. Now we will move to the task 2, the mortality data. The task 2 is based on the figure 2 from CDC paper by Ahmad, Sidgwick, and Anderson, published in August 2024 in the Morbidity and Mortality Weekly Report. The citation is in the app itself. The data is provisional 2023 figures from the US National Vital Statistics System. The causes and death list. The data are stored in two parallel Python lists, causes and death, each with the 10 elements. They are ordered from fewest death in index 0 to most deaths at index 9. That ordering is deliberate. When Portly renders a horizontal bar chart, it reverses the y-axis, displaying the last item at top. So heart disease, which is at index 9 with 680,909 deaths, appears at the top of the chart, matching the original figures. Data accuracy. Four values are exact counts from this paper. Heart disease at 680,909, cancer at 613331, unintentional injury at 222518, and COVID-19 at 49928. And the remaining six values, stroke, CLRD, Alzheimer, diabetes, kidney disease, and liver disease, were read from figure 2 in the paper because exact tabulated counts were not provided. This is noted in footnote on the chart. So now I will do the live demo for the tax 2. So the app opens with the horizontal bar chart on the left and an annotation panel on the right. Heart diseases is selected by default. You can see the bar is highlighted with a yellow or a gold color, and the right panel shows the details. So I'll now click on the cancer bar. So, so when we click on the cancer bar immediately turns a gold color, and the heart disease bar returns to navy, and the annotation panel on the right update to show cancer date count, its ranking as the second leading cause, and contextual information about why cancer dates may have increased in 2023. You can also select causes using the buttons in the right panel. For example, clicking the COVID-19 panel. So COVID-19 dropped from the fourth leading cause in 2022 to the 10th in 2023, 68.9% reduction. The annotation explains this and notes that when COVID-19 is counted as a contributing cause rather than the underlying cause, total deaths were 76,446. So now we will walk through the tax 2 code. So this is the code for tax 2. So tax 2 imports the streamlit and plotly graph object. We use graph object rather than plotly express because it gives us direct control over the bar colors, specifically the uh, ability to change color bar colors based on what cause is selected. After the data list, there is a last dictionary called annotations. It maps each cause name and exact string matching the cause list with a nested dictionary containing three keys, date, rank, and the context. The annotation had keying this dictionary by the exact string in important. It means we can look up the annotation for any bar with a single annotation. This design separates the data content from the rendering logic. If I needed to update the context paragraph for any cause, I only touch this dictionary and nothing else changes. The StreamWrite re-executes the entire script from top to bottom every time the user interacts with page. This main ordinary Python variable resets on every interaction. To persist the user selected cause between reruns, we use Streamlit station state object. So the if statement, the if statement means this default is only set on the very first run. On subsequent run, session state selected already exists with whatever the user has selected, so we do not override it. Just before the chart is created, we compute bar colors using a list comprehension. The bar colors, the this creates list of 10 color strings navy from every cause except the currently selected one, which gets gold. Because this runs on every rerun, the colors always reflect the current selection without any additional logic needed. The Oddly chart and on select, the chart is created with Go figure containing a single Go bar trace. The orientation is H for horizontal, and the marker color property is set to bar colors. The important part is ST broadly chart with on select set to return. This tells Streamlit to return the script whenever the user clicks on chart. The return value, which we store in event, contains information about what was clicked. S- So we check that even selection had points. We extract the y value from the first point, that is the cause name string. We verify it is annotation to make sure it is valid cause, and we write it to session state and call st return to force an immediate return. In the right panel, there is a secondary way to select causes, a set of buttons, one per cause. These are created in a for loop over reverse so that the most deadly cause appears to the top of the list. Each button has a unique key formatted as btn plus the cause name. The unique key is required because Streamlit uses keys to identify widgets. If two buttons had the same key, it would cause an error. When any button is clicked, it sets session state selected and calls st return, triggering the same update path as the chart click. So this is all about the code. So to summarize, what both the program demonstrate, the task one shows how to use Streamlit HTML injection capability to replicate a professional government data table, including custom CSS for styling and watermarking. And Task 2 shows how to build an iterative data visualization with Plotly, where user interaction update both the chart appearance and a contextual annotation panel using Streamlit session state. Thank you.